Hello. This is your transformation study guide key. What is the parent quadratic function? It's just a function of f of x equals x squared. X squared is the parent of a quadratic function. Which of the following quadratic functions will be vertically shifted up? Remember, a vertical shift has no parentheses. Now, none of them have parentheses going down through here. But this is your parent graph. This is vertically shifted up 2. There's a plus sign. This one's being vertically shifted down 3, and this one's a compression. You don't see a minus or plus, so it's letter B. Describe the transformation. Okay, here's the function right here. Move it a little bit so you can see it. It's y equals 2/3 x squared. Remember, if the number in the front is smaller than 1, it's a vertical compression. So this is a compression of 2/3. Which of the following is the parent? It's an exponential function. Remember, exponential has all kinds of bases. So it's very difficult sometimes to recognize the parent. But if you don't see any adding or subtracting like this has got, then that's how you're going to recognize it. So it's this one. This is your parent. And it's going to have just a number of some kind raised to a power. It doesn't matter what the number is. All of these are parents. A number raised to a power of x. How do the functions compare? This one's x squared, this one's negative x squared. Remember, outside, if the negative is outside the function, it's a reflection over x. The letter outside is O, and then it reflects over x. It actually makes the word ox, which is an animal. So when it reflects over x, you can recognize it because it's on the outside. Reflecting over y, it's not up here, but reflecting over y would be inside parentheses. This one is a reflection over y. So the answer to the question here is reflect over x. Okay, now we're comparing. This is your parent. Remember, when it's to the x power, that's your parent. The number in the front is bigger than 1, so this is a stretch, a vertical stretch of 8. Looking at this one, we have a minus sign. That's how you know it's a shift. If there are no parentheses, it's a vertical shift. So this one is vertically shifting down 2. This one has a negative sign on the inside of parentheses. It's reflect y. This one has a negative sign on the outside of parentheses. And it's in the front, reflect x. This one, no parentheses. Vertically shifts up. You see this one over here? Inside parentheses, so it's horizontal. And remember, horizontal movement does opposite of what our brain says. Our brain says that goes right. It doesn't. It goes left. So this is a horizontal shift left of 2. This has 3 things happening, and you have to be able to list them all on the test. This is the number in the front. It's bigger than 1. It's a stretch. Think of stretching your body. Multiply your body by 2. Your body gets stretched. So this is a vertical stretch of 2. This is in parentheses. It's a horizontal shift right, opposite of what we think. Remember, horizontal goes opposite of what we think. Vertical shift down of 5. This is our base. So this negative sign on the inside of the parentheses is reflect y. This inside is a horizontal shift left 2. This reflects x. It's on the outside of the parentheses. This is on the inside of the parentheses. This is outside in the front. It's reflect x. Inside parentheses is a horizontal shift right of 1. Outside of the parentheses does exactly what our brain thinks it'll do. It vertically shifts up 3. Now look at this graph. You see this? The best thing to do with this is to take all of those equations and type them into Desmos and see which one this one looks like. Now another thing to do, you see your asymptote right here at 2? If they all have a different asymptote, which they do, this one has an asymptote at -2, this one's at +2, this one's at -1 and +1. These numbers on the end are your asymptote, so it's letter B. But now, if you can't remember which number is the asymptote, you can definitely type these into Desmos and find that. This one, it says, which graph shows f of x translated up to? Here it is. Here's this asymptote at 1. Just take that and move it up 2. This one's going down 2 because the asymptote of the original function was at positive 1. This was at negative 1. It went down 2. This one's at 3. 1 plus 2 is 3. It's this one. This one stays right on 1, and this one stays right on 1. So one of these is a stretch, and one of them is a compression. So that's how you tell they're not being shifted up or down. All right, this says select all that apply. Now, I put little dots, little tick marks so you can see it. This is the original function right here. This is the one we're moving. We are moving it 1, 2, 3, 4 right, and we are moving it 1, 2, 3 up. So this is being vertically shifted right 4 right here, and vertically shifted up 3. So be careful on the test and be sure that you select all that apply. This one says the same thing, select all that apply. Here is the function, this is the parent. What's happening? I'm reflecting it over x. This is flipping over x, and look at the shape of this one. This one got skinnier. When your graph gets skinnier, that's a stretch, the same as if you multiplied your body by something, you would be stretched and be skinnier. Same thing. So this one is reflected over x, and it has a vertical stretch. All right, here's the graph that's been provided. This says to take it and move it up 4. That's outside of parentheses, so we move it up 4. So I'm just taking some points. This point here, I'm going 1, 2, 3, 4. This point here that we can see, 1, 2, 3, 4. Sketch the line. I just added 1 for good measure just to get the flow of it, but that's it. That's all you have to do. If it were horizontal, it would look like this, and it would be in parentheses, and this one would go left 4. You just take those points and march them left. Take this point, march it left 4. So that's the difference between vertically shifting up and vertically shifting left. Horizontally shifting left. All right, this one says to graph negative 2x plus 3 on the provided coordinate grid below. That's the grid, that's the graph in black. You can do this one of two ways. You can put it in Desmos and find it, and then transfer it onto your paper, picking points that are on the corner and plotting them. Or you can do it this way, which is, I taught you both ways in class. So positive 3, I start at 3 on my y-axis. My slope is negative 2, and I'm going down 2 to the right 1. Down 2 to the right 1, down 2 to the right 1. That's the graph in black. Then it says to shift it down 2. Literally take those points. You see I drew them in red, count down 2. And then put you a dot and make your new line. That's all there is to it. Now, if you wanted to put that in Desmos, you would put this in Desmos first. That would be the first one. And then you could do this and just tack a -2 on the end. You wouldn't even have to put like terms together. Desmos would do it for you. So you can find the other one just by typing that into Desmos. Both ways work. All right, this says find f of x minus g of x. We keep putting this on your test because some of you, not all of you, keep missing these. So this is f of x, write it in parentheses. This is g of x, write it in parentheses. When there's a minus sign, you have to distribute that negative sign throughout, which makes this negative 2x squared and positive 14. Then put like terms together. 4, and I underline them so you can see them. 4x squared and negative 2x squared are 2. 5x does not have a like term over here, so you just bring it straight down. Negative 8 and 14 are like, so negative 8 plus 14 is positive 6. What is the factor form of this? Okay, so I wrote it out with the x. I put 18 on the top, 9 on the bottom. I'm looking for factors of 18, which add to be 9. 18 is 1 times 18, 2 times 9, and 6 times 3. The two that add to be 9 are 6 and 3. And I just come over and write x plus 6, x plus 3. That's the way with the x method. If you are not comfortable factoring that way, you can put this into Mod 5.3 and it will tell you that your x1, and I don't know the order that it will put these in, but it'll give you x1 and x2, and it'll just tell you they're both negative. Now, it might do -3 first and -6 second. It doesn't matter. Realize that when you do it in Mod 5.3 is giving you the zeros of the function. But to factor it, remember this is asking for the factored form. To factor it, you just write the opposite of these. The factors are opposite of the zeros. What is the equivalent form of this one? All right, put it in Mod 5.3, literally. And Mod 5.3 gives 4 answers. It gives x1, x2. I can't remember the exact thing that it calls that third one, but it's the x coordinate of the minimum. I think that's what it says. X coordinate minimum, or if it's a maximum, if there were a negative here, it'd be maximum, but it'll tell you the x coordinate and the y coordinate. This is what Mod 5.3 says. -3, -1. Remember, this one, you have to do the opposite of it and write it in, and this one you keep the same. Now, another thing that you can do, you can take this equation and you can type it into Desmos and find the vertex. The vertex will be this point here, -3, -1. And then you just remember, we had a worksheet, remember, where we do the opposite of this. So it's x plus 3 minus 1. X plus 3 squared minus 1, which is this function right here. And that's old material. This is old material. This is material from first semester. Remember, we try to always wrap back stuff. Now, in Desmos, that's the easiest way to do this. Graph both of these equations in Desmos and see where they're crossing. In Desmos, you're going to find that they're crossing at the point 9,3. That is the easiest thing to do. To do this algebraically, I didn't do elimination because elimination is actually harder here. I did substitution. And you could graph these yourself on a graph grid, for that matter. That's another method. But I didn't do elimination, I used substitution. I wrote y equals 1/3 x over here. Then I put my harder equation over here, and I took 1/3 x because y is 1/3 x, and I plugged it in for y right here. So 2x minus 3 times 1/3 x. 3 times 1/3 is 1. 2 minus 1 is 9. 2 minus 1 is x, so that's 9. So x is 9, then you plug this back in. 1/3 of 9 is 3. You're still going to get the same answer whether you do it algebraically or you use Desmos. And I do believe Desmos is easier for you, but here it is by algebra. Remember, we did this stuff either right before Christmas or after Christmas. This is your graph characteristics unit. The difference here, you're not given the graph. You have to type the graph into Desmos and look at the graph yourself in Desmos. So you can type this into Desmos. You're going to get this graph. I put it here so you could see it. And you're being asked for the positive interval. Remember all those graph characteristics we did? We did domain, range, interval increase, interval decrease, positive interval, negative interval, in behavior, all that stuff. Okay, this is asking for the positive interval. This graph is positive above the x-axis. Anywhere above the x-axis, y is positive. Well, what values of x is that? From 2 to infinity. And that's the answer to that one. Thank you.